Hi, my name is Deanna Tanquero, and this paper focuses on the material polyamide Pa12. This paper is called The Influence of Processing Parameters on Tensile Properties of SLS Polymer Product by Anna, Tomas, and Igor. This paper investigates tensile properties in SLS and how they are affected through varying parameter selections. They address a new mathematical model to calculate energy density and again on how various process parameters affect tensile properties. The image to the right shows the material and various parameters that I will talk about in the next slide. The material used was, again, polyamide Pa12, and they also used a machine called Formifov P100 for measuring the tensile properties. The different processes, or the different process conditions studied were energy density, um, and various others, but energy density, you can see the formula of energy density there to the right. Previous papers have always used the first formula, but had always seen problems with the fit and function of the part. So this paper investigated an expansion of the formula, which is what you see to the left, and this is to include more process parameters to achieve a more accurate model. Laser beam speed was also investigated, which is V in the formula, and it's just as it sounds. It's the speed of which the laser scans the layer, and the faster the speed, the faster the manufacturing time. The next is laser power. P is used as a percentage of the maximum laser source power. This depends on the type of material and layer thickness in which or with which the part is built. Hatch distance H is shown in the image below. This is related to the laser beam diameter, which is constant. The hatch distance should be typically smaller than that of the diameter in order to guarantee a connection between the hatching lines. And the overlay ratio is a relation between the diameter and hatching distance. It's the diameter divided by the hatching distance. Um, the first graph, so some of the results of this research, the first graph shows the results of the tensile properties as chamber temperature is changed. The second graph on the right shows the results of the tensile properties when both overlay and energy density remained constant and power and speed were changed. As you can see from both graphs, neither chamber temperature nor power and speed had a significant effect on tensile properties. The first graph on the left shows the tensile properties of an increasing energy density. The graph on the right shows an increasing overlay ratio. As you can see from both the graphs, the tensile properties both showed improvement with these changes, but a limit was observed. So the properties or the variables were changed from specimen 1 to 9, as you can see, 1 being the lowest, 9 being the highest. As you can see from specimen 9 in both graphs, there shows a significant drop in properties. So there is an upper limit of improvement in tensile properties as both energy density and overlay ratios are increased. In conclusion, this paper showed tensile property results for each of the process parameters mentioned in the before slides. The energy density and overlay ratios showed the most effect in tensile properties. The tensile properties remain the same for varying power and speed, but it was found that an increase in energy density and overlay ratio both showed an improvement in properties up to a certain limit. The limit for best properties was established to be 0.0484 through 0.0667 joules per millimeter squared for this specific material. Specimens were also looked at after fracture and found that overlay ratio had an effect on how the sample fractured. So for example, overlay ratio less than 1 showed a straight line fracture, whereas overlay ratio greater than 1 showed a narrowing and material in the direction of force of which it fractured. My personal opinion and critique of this research is that it was very well constructed, very informative. It had a lot of information and shared the results very well. It would be interesting to see other shapes tested in this same manner to see if the results observed follow the same trends, as well as different materials. Thank you.